Limits number 10 is all about the intermediate value theorem, and it is just abbreviated IVT, and we call it an existence theorem because all that it does is it proves that something exists without really telling us how to find it. And we have the words of the IVT over here, but let me just kind of paraphrase what it means. So I've got this function, and it is a continuous function, and that's going to be important to us. And its y values go from f of b all the way to f of a. So what the IVT says is that my function is guaranteed to take on all the y values between f of b and f of a, and it's going to happen on an interval. That x value where we take on that y value will happen on the interval from a to b. If that sounds a little vague right now, as soon as we do a few examples, I think it will help you to understand what it means. And the first one is just a practical application and how you use it without even really thinking about it. So this says that the temperature at 6 a.m. is 82 degrees, and at 11 a.m., the temperature is 98 degrees, and you have to explain why. There must have been a time when we hit the 90-degree mark on the thermometer. And if you just use your common sense, and I'm going to use my awesome drawing skills right here. So if you have a thermometer, and at 6 a.m., you're reading at 82 degrees, so 82 degrees, and at 11 a.m. you're up to 98 degrees, then you know to get from 82 to 98, you've got to hit all these in-between numbers. You're going to hit all the numbers in between 82 and 98, and 90 degrees is just one of those numbers. And it's going to make sense that it's going to happen sometime between your 6 a.m. temperature of 82 and your 11 a.m. temperature of 98. The explanation as to how you know that is true, that is the IVT in action. And our first requirement is that you have to have a continuous function, and you have to say that. So I just lay out that temperature is a continuous function, and the next thing I have to do is position this number in question in between the two numbers that I'm given, the 82 and the 98. So I just establish that my 90 falls in between the 82 and the 98. And what I've done so far is I've just laid out the conditions necessary to use the IVT. So I'm just going to say, all right, so now I'm allowed to use it. And I just lay that out as part of my statement, so by the IVT. And I'm just going to say what the IVT claims, and that I am going to hit that 90 degrees sometime between 6 and 11. And then I just say that there is a time between 6 a.m. and 11 a.m. when the temp equaled 90. Notice I didn't know what time it happened. It could have happened at 6:30. It could have happened at 10:59. All I'm saying is I know there's a time between 6 a.m. and 11 a.m. when I hit the 90, because that's the only way you're going to get from 82 to 98 is to bypass the 90. So these are the important aspects of using the IVT. You have to state that you have a continuous function. So my temperature is continuous. You have to position that number in question in between the two given numbers. It is always good to mention a theorem if you know what you're using. And then just that interval, I know that it's going to be in between 6 and 11. The next question says to use the intermediate value theorem to show that f of x has a 0 on the interval from 0 to 1. So first of all, what it means to have a 0 is that f of x equals 0. So the first thing I'm going to do is find what f of 0 is and f of 1. So what I find is that f of 0 is -1 and f of 1 is 2. If you just think about it logically, if you think about it on a graph, if I'm going to start at the point 0, -1 and head to the point 1, 2, it doesn't matter what this graph looks like. To get from this point to this point, I need to cross over the x-axis, and that's when my f of x is going to equal 0. So since my y values go from -1 to 2, from a -1 to a 2, I'm going to have to bypass that 0 at some point. And it's going to happen on the interval from 0 to 1. I don't know exactly where. All I know is that it will happen. So now that I have kind of made a plan in my head, I'm going to follow that same sort of a template that I did above. So the first thing I need to do is say that my function is continuous. And this is just a cubic, and all polynomials are continuous. So now that I've said that, I need to position this 0 in between these two values. So I just say my 0 is in between the -1 and the 2. And the next thing I'm going to do is mention that now I can use the IVT. So I've just mentioned by the IVT. And now I just need to say, therefore I know that there will be a number in between 0 and 1. So a number on this interval from 0 to 1 where that function value will equal 0. So there's a number C on the interval from 0 to 1, which is this interval here, where f of c equals 0. So just notice the different parts of this. I lay out that f is a continuous function. I position that 0 in between the -1 and the 2. I mention that I'm going to use the IVT. And the last part is I just draw the conclusion. Therefore, there is a number on my interval where the value of the function is going to equal 0, where I have a 0. This is a really important concept. The IVT is almost always tested on the free response part of the AP exam. And so you just have to be very particular in how you lay it out. And you can pretty much use this as a script. Just make sure you have all of those components showing up. It does sometimes show up as a multiple choice question, as you see in number 3. If you want to give this a pause and maybe give 3 a shot on your own before I talk about it. So what this is saying is I've got a continuous function, which I need my function to be continuous, on a closed interval from -2 to 1. And f of -2 is 3, and f of 1 is 6. So my y values are going from a 3 to a 6. What that means is I'm going to hit every y value in between 3 and 6. And as I look at my options A, B, C, and D, option A says f of c equals 4. When you see f of c, that's just your y value. So these are my y values over here. What the IVT guarantees is I'm going to hit everything between 3 and 6, which 4 falls within that range of numbers, which means I'm not going to choose B or C. I'm going to go for either A or D because it fits that first requirement. Now for the interval it's going to happen on, it's going to happen on this interval that I'm given somewhere between x equals -2 and x equals 1. So I can see that my answer here is going to be D. You can also make sense of this graphically. So if you do a quick sketch of these ordered pairs, and you can see from this sketch, if I'm going to go from this ordered pair of -2, 3 to this one, which is at 1, 6, I'm going to hit every y value from 3 to 6, and 4 just falls within that range. And I'm going to do it on this interval between -2 and 1. And here's one more example. And it's very AP exam multiple choice like. This information is given in a table. And again, the first thing I need to do is verify that I have a continuous function. So G is continuous. And I have selected values of G in the table. And I want to know where g of x is going to equal 3. So when I see g of x, that is a y value. So I want to know on what interval am I guaranteed to have a y value of 3. So I just take a look at the y values right here. And if I'm going to go from a y value of 0 to a y value of 4, I'm going to take on all the values between 0 and 4, and 3 is included in there. So I actually hit it on that first interval. It's going to happen on the interval from -1 to 2. So the answer here is A. If we take a look at the other intervals, if I go from a 4 to a 9, I'm not guaranteed to hit a 3 in there. I could, because I don't know what this function actually does, I might hit 3 if this takes a dip down, but I'm not guaranteed to hit a 3. And the same for between 9 and 15. I will take on all the y values between 9 and 15, but since 3 doesn't fall within that range, I'm not guaranteed to hit a 3. I could, but it's not a definite that I will. And that's pretty much it for the IVT. Just some things to remember. Sometimes a sketch might help you if you get stuck with things. And if you have to say things in your own words, just kind of follow this script. I guess that's not really saying it in your own words, but just make sure you have all of these components, your continuous function, position that number in between the two that you're given, mention the theorem, and then just draw your conclusion.